Hello everyone, this is Lesham. In this video, I'm going to present a demo called Automating Software Citation using GitCite. The motivation for my work is that software source code is an important form of research product which should be cited. Various organizations, such as Force 11, have argued the need for software citation. Organizations such as the Software Heritage and the Nodal address the preservation of software products, and platforms such as GitHub help with collaboration and share over software projects. However, none of these address the problem of generating and managing fine-grained citations to components of repositories. So what's hard about software citation? A software repository is a complex, evolving structure with many contributors. Current citation practice credits the owner of repository but does not acknowledge contributors. The problem is that we need fine-grained citations for components of projects, crediting to contributors and sources from which components have been taken. Challenges include granularity, meaning that the different files should have different citations. In many cases, files may also share common citations, which we call modularity. Moreover, citations should be compatible with a heavily used Git model, which means usability. And there is a tension between these three issues. To solve the problem, we provide GitCite, a fine-grained software citation system that is compatible with Git and GitHub and manages citations for files in the repository. Now we briefly discuss the model. To address granularity, each version in a project has an associated citation function which, given a path in the tree, returns a citation for the file at the end of the path. For modularity, we do not require that every file has an explicit citation, that is, the function can be partial. A citation for version V of repository P at directory location N is defined as follows. If N has a citation defined, return its citation function, CPVM. Otherwise, return the citation function of its closest cited ancestor A, CPVA. We provide some basic operations for the citation function, including adding, deleting, modifying citations to files, and carrying citations through Git operations like merge branches, copy subtrees, and fork repository. Here is a figure of the architecture. We provide a browser extension working with GitHub that allows citations to be generated for any file directory in any version of a software repository, and added, modified, deleted by project collaborators. In addition to these functions, the local executable tool also enables citations to be managed through Git repository level functions such as merging branches, copying subtree, and forking repository. Since different people interact with the system in different roles, a project member can add managed citations attached to project components. A citer can request the citation for some component, and the reader can dereference citation to obtain the software being cited. Now it's a time for a demonstration scenario. In order to show the demo, I start with two sample repositories with attached citations. For the local citation tool, the first thing to do is to enter the path to the local repository on your computer. After clicking Load Repo Info, the tool will show the metadata and the visualization of the directory and the file nodes on the right-hand side. Those with attached citations are in blue, and other nodes are in gray. At the top in the middle, by entering the location of the file, you will be able to see the citation for that file, either the one attached if it's defined, or the one inherited from its closest ancestor. You will also be able to add, modify, or delete the attached citation. By comparing the citations for different folders, you can see that the default citation at the root is different from the citation for the folder called Java New. In the current case, it was introduced by copying files from another repository with citations. If you want to borrow code from others and keep their citations, you can specify the remote URL of the repository, the version, the remote file or folder, and a destination folder to put the code. After clicking the button, the files and citations will be copied to the current repository, and the commit histories of the copied files will be also maintained. If there are two different branches with citations in the current repository, you can perform a merge with citation. To resolve citation conflicts, you can choose to keep the current version as much as possible, keep the citation of the other branch, or manually resolve conflicts. By clicking the button, files are merged and the citations are combined under the specified policy. After all changes have been resolved, the repository author can choose to commit and push to remote repository. For the web tool, we provide a Chrome extension for fast access to citations on GitHub. It allows citation generation for all users and immediate citation modification for project members. The web page view corresponds to a particular version of a file for which the citation can be generated. By default, it will be the latest version of the master branch. The only difference from the local executable tool is that any change in citation will be instantly committed to the remote repository rather than when the updated version is committed and pushed. That's all of the video. If you are interested, welcome to read our paper and raise questions during the online conference. Thank you for watching.